Now let's take a look at an example. I want to find the area under the curve on the interval from 0 to 1 using the right endpoint and left endpoint. So the curve of this graph is look like this. It's a parabola, okay? And we want to find it from 0 to 1. So we want to find the area from here. So we want to find this area using the approximation on right endpoint and left endpoint. So now, first of all, we will find delta x. Delta x is b minus a over n, which is the second number minus the first number and divide 5. So that is 1 over 5. So that is my delta x. So my because I divide that into 5 rectangles, so I will have 1, 2, 3, 4 value, because you're gonna have 1 rectangle, 2, 3, 4, 5. So you will have 4 extra value in the middle for the n equal 5. So I need x1, x2, x3, and x4. So how do I find x1? My x1 will be delta x will be 8 plus delta x, right? So my a in this case, 0. 0 plus delta x is 1/5. So my x1 is 1/5. And what is my x2? My x2 is a per 2 delta x. It will be 0 per 2/5, which is 2/5. Or the other way that I mentioned to you earlier, instead of to apply this formula, you can keep adding 1/5 to whatever the result. So you have x3 will be 2/5 plus 1/5, and that is 3/5. And then x4 will be 3/5 plus 1/5, and that is 4/5. Okay, so this is my x value. And for the right endpoint, we have area of the right. So it's going to be delta x, f x1 plus f x2, f x3, f x4, and fb. This is the formula. Of course, when you do the problem, you don't need to write out a formula. It's just for me to show you how do I put that in. So now my delta width is 1/5. So I have f of 1/5 is f of 1/5 for x1, and then f of 2/5 for x2, f of 3/5 for x3, and then so on. Okay, so when you're putting all this, and then you can substitute 1/5 to your x, and then 2/5 to your x. So we will have 1/5. And then now, when we write out all the step, we will put into the calculator to approximate the value. So 1/5 times 1/5 square, 2/5 square, and that will give you about 0.44. Okay, 0.44. So because this is concave up, increasing, concave up, increasing function. Okay, the graph is increasing. And when we use the right endpoint, if you look at this concave up increasing function and you use the right endpoint, you know this value is actually overestimate. Okay, this is overestimate. Estimate. Okay, now we take a look at left endpoint. So when you have right endpoint, the left endpoint is going to be more straightforward, because all you have to do is you're going to replace your FB by FA. So everything stay the same. So 1/5, 1/5 square per 2/5 square per 3/5 square And instead of the last value is 1, you will replace by the first value, which is the 0, so 0 squared. Okay, and then we're gonna multiply the value. So instead of 1 square, you're gonna have 0 square. And that will give you 0.24. And if you have the concave of increasing, the right endpoint will be underestimate. Right. Okay. So the problem doesn't ask for underestimate or overestimate, but if the problem asks, then you can look at the graph to tell whether it's overestimate or underestimate. And if you want to more accurate and better approximate the x squared, you're gonna have the average, which is 0.44 plus 0.24 over 2. And that will give you 0.38. You know that your area under this region is really close to 0.38, okay? But of course, there was still some estimate error. And you will know, you will learn how to find the exact area under x squared using some other technique in the next few sections.